Imagine a world where gravity vanished. The force that anchors us, governs the fall of a raindrop, and keeps the moon in orbit, gone. Instantly, everything not bolted down would drift upward, a chaotic ballet of floating objects. Gravity has shaped every living thing, from whales to insects. Without it, the rules of existence would change in a heartbeat. Today, we'll explore what life is like without gravity and the technologies that help us study this phenomenon. Our journey takes us from Earth to the International Space Station, where weightlessness is a daily reality. This is the story of our dance with the cosmos, a tale of adaptation, innovation, and our quest to understand the forces that shape our universe. If gravity disappeared, your coffee would float, your chair would drift, and even the air would escape into space. Gravity is the silent architect of our world, shaping our bodies, landscapes, and atmosphere. Every action, walking, running, standing, relies on its presence. But what if we could escape it? Not by removing it, but by entering a state of continuous freefall. This is microgravity. In orbit, like on the International Space Station, astronauts are always falling around Earth, creating the sensation of weightlessness. This environment is both a challenge and an opportunity, a laboratory where physics and biology play by new rules. How do fluids behave? How does the body adapt? These questions drive our exploration of the weightless frontier. Our journey into this world begins with learning to float. To study weightlessness, scientists simulate microgravity on Earth. Drop towers create seconds of freefall by dropping experiments in a vacuum, offering a brief taste of zero-G. Parabolic flights, nicknamed vomit comets, fly roller coaster arcs, giving astronauts and researchers up to 25 seconds of weightlessness at a time. These flights are crucial for training and experimentation, but the experience is fleeting. For true, sustained microgravity, we look to the International Space Station, our laboratory in the void. There, weightlessness is not a momentary state, but a way of life. Let's see how we've built a home in the heavens. The International Space Station, 250 miles above Earth, is a marvel of engineering and international cooperation. In microgravity, there's no up or down. Astronauts use every surface to work and move, gliding through modules with handrails and footholds. Equipment is tethered, air is constantly circulated, and water is recycled from every possible source. The ISS is a closed-loop ecosystem, a blueprint for future space habitats. Life aboard means adapting to a world where you push, not walk, and where orientation is always relative. The station's design teaches us how to survive and thrive beyond Earth. It's a living machine, preparing us for deeper space exploration. Here, the challenges of weightlessness are met with ingenuity and teamwork. Our bodies evolved for gravity. In space, they change fast. Fluids shift upward, causing puffy faces and skinny legs. Headaches and congestion are common. Muscles weaken and bones lose density. Astronauts can lose over 1% of bone mass per month. To fight this, astronauts exercise up to 2 hours daily on treadmills, bikes, and resistance machines. The body must be trained to remember gravity or risk returning to Earth fragile. Microgravity reveals how deeply gravity shapes our biology. Every day in space is a battle to stay strong for the journey home. The human body, built for Earth, must adapt to survive among the stars. Daily life in microgravity is a constant adjustment. Astronauts sleep in tethered bags, eat sticky foods to prevent crumbs from floating, and use rinseless soap for hygiene. Water floats in spheres, and even brushing teeth requires swallowing toothpaste. Movement is a gentle push and glide. Tools are always tethered, and every action is three-dimensional. Leisure changes too. Sports become slow motion, and socializing means floating in clusters. Every routine task is re-engineered for weightlessness. Life aboard the ISS is a reminder of how gravity shapes our habits. For astronauts, floating is the new normal. For long missions, we need more than adaptation. We need artificial gravity. By spinning a habitat, centrifugal force can mimic gravity, pushing inhabitants against the outer wall. Rotating space stations have been imagined for decades, and small centrifuges already help research on the ISS. These devices let us study gravity's effects and could one day keep astronauts healthy on journeys to Mars. Artificial gravity isn't just comfort, it's key to long-term survival in space. Future spacecraft may include spinning modules as a gravity prescription. Bringing gravity with us could be the next leap for humanity in the cosmos. Our journey from drop towers to the ISS shows how gravity shapes every aspect of life. Studying weightlessness gives us new appreciation for this invisible force. As we prepare for missions to the Moon and Mars, these lessons are more vital than ever. The challenge of living without gravity is immense, but so is our capacity to adapt. So, how would you